Today's our final day of notes on radicals, so we learned how to simplify them. We learned how to add and subtract them. The obvious next step is to multiply and divide them. Remember, product means multiply, quotient means divide. So today we'll be multiplying and dividing radicals. Since this is the last day of notes on radicals, that should tell you that there's a quiz coming up. There is a quiz on Friday, so we will review tomorrow everything we did in the last 2 weeks. So triangles, the first page of the quiz is triangles, the second page of the quiz is radicals. So you need to remember both for Friday. If you need a refresher, that's what tomorrow's all about. Any questions before we get moving? All right, first, products of radicals. So go ahead and copy these down. We'll talk about them in just a minute. So just like yesterday, the basic concept isn't too challenging. The challenging part is actually still just Monday's lesson. So actually multiplying these shouldn't be too difficult once you learn the rule. But again, we still have to simplify anytime we can, so that might be where you get hung up. Hopefully not, though. Hopefully not by now. But here are the steps. So the first thing we want to do is multiply the coefficients together. The coefficients are the numbers outside the radical. Then you multiply the numbers inside the radical together. Then you simplify. So outside stays with outside, inside stays with inside. You'll notice they do not have to be the same number. That's only when you add and subtract. Multiplication and division has a totally separate set of rules. The only thing really that's important when you're multiplying and dividing is it inside a radical or is it outside of a radical? Outside stays with outside, inside stays with inside. And that applies to division as well. When we're dividing, you got to keep the outside with the outside, the inside with the inside. So here are the first 5 examples. These are all the multiplication ones we're going to do, and then we'll talk about division. And then hopefully have a little time to do your homework. All right, so we said outside multiplies with outside, inside multiplies with inside. So number 1, do we have anything outside the radical? Do we have anything inside the radical?
Yes.
Yeah. So multiply those together. What do you get? 6. So the answer here is square root 6. Now, normally we would do a factor tree. We've seen the factor tree for square root 6 several times. Remember, it's just a 2 and a 3. There are no repeaters, so it doesn't simplify. So there you go. Done. What are your questions? All right, same thing on number 2. What am I going to get? 18. Good. Now this one is a little different. Why? Because you can do a factor tree. Oh, I'm still on number 2. Not done yet. 9 and 2, and then 3 and 3. So what comes out front? The 3s. And then what's in the inside?
2.
The 2. So we have 3 square root 2. So again, that one was just a little different because you could do a factor tree and it did have repeaters. So again, the tricky step is often just what we learned on Monday is the simplifying. Once you remember your multiplication rules, these shouldn't be too difficult. All right, next. Whenever I see this little guy, that means I have this, the base, how many times?
2.
Twice. Good. So this is actually square root 2 multiplied together twice. Or square root 2 times square root 2. Which would give us what?
4.
Square root 4. And what is the square root of 4? 2. Very good. A lot of people mess up between here and here because they want to leave it as the square root of 2. That's not right. Remember, once you realize that 2 times 2 gives you 4, you drop the square root. You already took the square root, drop it, okay? Questions on number 3? All right, number 4, again, I see a little exponent of 2, so how many times do I have 3 square root of 2? Twice. Now, this is the first time that I have numbers outside the radical. What do I do with those? What am I doing with these expressions? Multiplying. So just multiply the numbers outside with the numbers outside. What do I have on the outside? 9. What do I have on the inside?
4.
And what's the square root of 4? And what's 9 times 2? 18. Your answer here is 18. No square root. Once you took the square root of 4, it became a regular old 2, and then you multiply them. Excuse me. Whoops. All right. The bottom, now it's to the 3rd power. So how many times do I need to write 5 square root 3? 3 times. So 1, 2, 3. Outside multiplies with outside. So I need to do 5 times 5 times 5. Oh, careful. What's 5 times 5? What's 25 times 5? $100 and you have 5 quarters. Yeah, 125. Square root, and then we have 3 times 3 times 3. What's 3 times 3? 9 times another 3.
12.
9 times 3?
27.
27. Good. Now, some of you might say, oh, we're done. Why aren't we done? You can make a tree for 27. We just said that 27 was made up of 9 and 3, so break it down to 9 and 3. So the 3's come out. So I need to multiply the 3 that I'm pulling out by the number that's already out here. What's 125 times 3? 375. Square root, what's left over in there? 3, good. All right, that is multiplying radicals. What are your questions? Ready for the real fun to start? Dividing. Dividing usually always seems to be the hardest. Ready for it? All right, here are the rules. Remember, quotient is the answer to a division problem. So here's how you find the answer to the division problems, the quotient of radicals. There's really just one very, 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 very important things to remember when you're dividing radicals. You can't have radicals in the denominator. Where's the denominator? The bottom. So if you have a fraction and you have a radical in the bottom, you got to get it out of there. Okay? We call that rationalizing the answer or rationalizing the denominator. Then you got to simplify. Sometimes you can simplify first, sometimes you can simplify at the end. The division problems, it just kind of depends on how it's given. So we'll look at a few different ways that you'll see them. And then I'll give you your homework. If you feel like there's one on your homework that we didn't quite cover, we can definitely do it on the board. Like I said, depending on how it's written or how the numbers simplify, these are sometimes easier to do one way over the other. So I'll try to show you a couple multiple forms on how these will be given. The cool thing about these is there's often a few different ways to get them started. And if you do it right, you should always end up at the same spot if you do it a different way. All right, write these two down. Here's two ways you might see them. You might see a radical in the top, no radical in the bottom. You might see one fraction and a big radical. Sometimes you'll see radicals top and bottom. Sometimes radicals just the bottom. Just all depends. So, I told you that the most important thing is that you don't have a radical where? At the bottom. Do we have a radical at the bottom for number 6? No. No, so that's good. The other thing you want to see is everything simplified. So can we do a tree for 5? No. Can you simplify the 3 with anything? No. Number 6 is actually already done. There's nothing more you can do. But those are the basic things you want to check. Is there a square root in the bottom? Can you simplify using a factor tree? And are there any fractions that you can simplify? And in this one, there's just not. So the answer here is actually just square root 5 over 3, which does occasionally happen on these problems. So you might look at one and say, there's nothing to do. Sometimes there is really nothing to do. All right, when they give you one big fraction like this, see if you can simplify it. Can we simplify 5/6? Like, is there a number that goes into 5 and 6 that we can divide out? No. So what you want to do on a problem like this is change it to 2 square roots. We can do the square root of the top and the square root of the bottom. Now, there's something going on here that I told you could never, ever, ever happen. What's the problem? The radical in the bottom. The square root 6 has got to go. Here's the trick. If you want to get rid of the square root 6 in the bottom, you need to multiply the top and the bottom by the square root of 6. That's the trick. It's magic. It always works. The reason it always works is it always gives us a perfect square in the bottom. What is 6 times 6?
36.
And what is the square root of 36? 6. So do you see how that got rid of the square root in the bottom? It's a trick. Always works. Just multiply top and bottom by whatever's in that square root. But we still need to figure out what's going on in the top. So what's square root of 5 times square root of 6? They're both in square roots, so just multiply them. What's 5 times 6? 30. So I have square root of 30, square root of 30. This was actually on your homework the other night. If you do a factor tree for 30, just for fun, you don't have any repeaters, so that one cannot simplify. So once you're at the end, think, did I get rid of the fraction? Or sorry, did I get rid of the radical in the bottom? I did. Can I simplify any of the numbers outside the radicals? No. Can I do a factor tree for any numbers inside the radical? No. So that's when you know you're done. Questions on number 7. Again, the trick is to multiply the top and the bottom by whatever is in the square root of your denominator. Questions? All right, here's 2 more, and then I'll let you have some time to work on your homework. This class ends at 10:55. Okay, so the first step that we did on the last problem where we broke it up into 2 square roots, that's already done, so we're good. What do you guys think we should do next?
Keep it the same.
What do you mean by keep it the same? Keep what the same?
It's already finished.
Not yet, because we have a radical on the bottom. How am I going to get rid of the square root of 2 in the bottom?
Square root 2.
Yeah, you multiply the top and the bottom by square root 2. What do you get on the top? What's square root of 3 times square root of 6? Oh! Did you hear what I did?
6.
What's the square root of 3 times the square root of 2? The answer is square root of 6. I got ahead of myself. Sorry about that. I know you're all very excited to answer. On the denominators, we have square root 2 times square root 2, which is what? Square root 4. One of those is a perfect square. Which one?
4.
Yeah, what is the square root of 4?
2.
2. And then square root 6 does not simplify. You can do a factor tree for it. You just get 3 and 2. There's no repeaters. A very common mistake I see at this point is people want to make this square root 3. Why is that not okay to divide these two? What's different about them? Why can't I divide these? Why can't I make this square root 3?
Both of them have square root.
Right, both of them are not square roots. This one is in a square root, this one is not. Okay, in order for you to be able to simplify, they need to either both be in square roots or both be outside of square roots. So this one is done. You cannot mix these together. No intermingling. Any questions? Alright, how should I start number 9? What's the problem? Let's start there. What's bothering my fraction right now?
Top is not a square root.
Okay, the top's not a square root, so I can't like simplify the 6 and the 3.
So do we flip it?
Sorta. What do I want to do? You're recognizing that the square root of 3 can't stay in the bottom, right?
So we square root about 3.
Yeah, you multiply everything by the square root of 3. And you might be like, how does that work mathematically? Anytime you multiply by the same thing on top and bottom, it's like multiplying by 1. So this is kind of like multiplying by 1. We're just manipulating what the numerator and the denominator are, so it works in our favor. Okay, so I am multiplying top and the bottom by square root 3. These do not actually multiply. You can't make it 18 or square root 18 because this is outside of a radical, this is inside of a radical. So this is just 6 square root 3 over, what's square root of 3 times square root of 3? Square root of 9. And what is the square root of 9? The number 3. Good. No square root. Now, this one can go a step further than any problem we've looked at so far. I'm going to give you guys a second to see if anyone can find it. Yes.
Do we multiply the 3 with the square root 3?
Not quite. He wants to do something with the 3's, but one 3's in a square root, one 3's outside of a square root. So we
multiply the 6 and 2?
you're close. We can't multiply them, but what can we do with these two? Yeah, you can simplify those. What is 6 over 3? 2. So this is actually 2 square root 3. Remember, outside stays with outside, inside stays with inside. So this 3 cannot do anything with the 6 and this 3 because these are outside, this one's inside. Okay, but since these are both outside and 3 goes into 6 twice, you can actually do the division here and you end up with 2 square root 3. Other questions? Alright, I'm going to give you guys your homework. It's only 10 questions. I encourage you to work until the end of this hour. And if you have like 1 or 2 that you just can't quite figure out because we didn't really cover exactly how to do it, just bring it in tomorrow. Tomorrow is a review day, so we can spend a little time going over your homework before we review. But give it your best shot. It will be due tomorrow. You won't have time to do the whole thing in class, so don't say you didn't know how to do any of it. But like I said, if you need to skip like 1 or 2, it's not the end of the world.